All right, today we are diving into something that is, quite literally, all around us. How artificial intelligence is completely changing the way we build our world. We're talking about the very bones of our society. The bridges, the buildings, the aircraft. This is about building the future, but a whole lot smarter. Let's get into it.
So I want you to start with this one question. Just let it sit in your mind for a second. What if we could design things not with brute force, but with the same kind of elegance we see in nature? This idea is the spark behind a massive revolution in engineering. And you know what? AI is the key that's finally turning that spark into a fire.
Okay, before we go any deeper, let's just quickly get on the same page with two key ideas. First up is stiffness. Just think of it like a material's personality, how much it resists bending. A brick is super stiff. Then you have deflection. That's how much it actually does bend, like a pool noodle. The entire game of building stuff that doesn't fall down is basically a balancing act between these two.
So that brings us to the modern material challenge, and really why our old ways of doing things are starting to hit a wall. I mean, for hundreds of years, our engineering formulas have worked pretty well, right? But the problem is, we're now asking our structures to do things they've never done before, to be lighter, stronger, and way more efficient. And our old rulebook just isn't cutting it anymore.
Think about a material like steel. It's fantastic because it's predictable. It's the same everywhere. But that uniformity, well, that's also its greatest weakness. It's a total one-size-fits-all solution. So to make sure one tiny part of a beam is strong enough, we have to make the entire beam that strong. And that just leads to structures that are way heavier and way more wasteful than they need to be. We're basically over-engineering for the weakest link.
So what's the solution? Well, it's this whole new class of materials called functionally graded materials, or FGMs. And the idea is actually pretty simple. Instead of being the same everywhere, the properties change gradually. The absolute best way to picture this is to think about bamboo. It's super tough and fibrous on the outside where it needs the strength, but it's lighter on the inside. It puts the strength exactly where it's needed and nowhere else, kind of like our own bones. Okay, but these new materials create a brand new problem, right? How in the world do you measure the properties of something that is literally different from 1 millimeter to the next? Your old school stress tests won't work. You need a completely new way to see what's actually going on under the surface.
And that's where this incredible technology called digital image correlation, or DIC, comes into play. You can basically think of it as a CAT scan, but for materials. So here's how it works. First, you spray a random pattern of little black and white speckles onto, say, a beam. Then you point some high-res cameras at it. As you start to bend the beam, some pretty clever software tracks the movement of every single one of those speckles. What you get is this amazingly detailed 3D map of exactly how that material is bending and stretching in real time.
And this is where we hit the heart of the problem. This technique creates an absolute tidal wave of data. We're talking more than 1 million data points every single second. There is no way a human engineer, or even a whole team of them, could possibly sort through that information. And that is precisely the moment when AI stops being just a cool idea and becomes absolutely essential. So we have the AI analyst at work, making sense of this data flood. You've got this unbelievably rich, but also unbelievably chaotic data set. What do? Well, you hand it off to an AI. These algorithms are just built to do one thing really, really well: find the signal in the noise. They can turn millions of shifting pixels into a crystal clear map of where a material is strong, and more importantly, where it's weak.
And this isn't science fiction. Let's look at some actual examples from the research. So for timber beams, the AI can scan all that DIC data and instantly spot hidden knots or defects that would create a weak spot. For something like a road surface, it can figure out the really complex ways the different layers of pavement bend and flex under traffic. Or for something incredibly precise, like a mirror on a space telescope, the AI can predict how tiny, microscopic misalignments in the layers could cause the whole thing to warp. In every single one of these cases, the AI is seeing what our eyes just can't.
And hey, don't just take my word for it. The researchers are proving this out right now. A recent paper from Prokowski and their team puts it perfectly. They say that AI-driven analytics are enabling improved detection of stiffness reductions and material defects. In other words, AI is giving them a kind of engineering X-ray vision. It can see the flaws. But that's only half the story.
Okay, so we've established AI is a brilliant analyst. It's a top-notch detective. But what if it could be more? What if it could go from simply finding problems in existing materials to actively helping us create brand new, better ones? This is the huge leap we're seeing now. AI isn't just an analyst anymore. It's becoming a creative partner.
And to make this creative leap, where do engineers look for inspiration? Well, once again, they looked to nature. And this time, they found it in a pretty surprising place, the exoskeleton of a scorpion. Yeah, you heard me right. They wanted to figure out how this thing could be so ridiculously light and yet so tough.
And what they found was that the scorpion's armor is a masterclass in this idea of graded stiffness. So imagine a tiny crack starts to form. As it travels through the armor, it runs into a layer that's much stiffer, and instead of just plowing through, the path of the crack actually gets deflected. Its energy just fizzles out. The armor literally steers the damage away. And now, with AI, we can model and perfectly optimize those same gradients to build our own materials that are just fundamentally tough.
So how does the AI pull this off? Well, it uses these amazing tools called genetic algorithms. The best way to think about it is like the AI is playing Mother Nature. It generates thousands of different designs, tests them all, and then breeds the best ones together to create a new generation of even better designs. It does this over and over, millions of times, until the design literally evolves into the perfect solution, the absolute best balance of weight, strength, and flexibility. It's digital natural selection.
Okay, so let's zoom out. What does all of this actually mean? Well, this isn't just some cool experiment happening in a lab. This partnership between AI and new materials is changing the actual blueprint for our physical world. We're shifting away from the old model of just building something and testing it till it breaks, and moving to a new model of predictive engineering, designing for perfect performance from the very first atom.
And the payoff here is just huge. We're talking about cars and planes that are lighter and way more fuel efficient. We're talking about bridges and buildings that can handle earthquakes or extreme weather better than ever before. We get machinery that runs smoother and lasts longer because it can cancel out vibrations. We can even build smart structures that actually adapt to their environment. And maybe the most important thing of all, we can build in real-time health monitoring, so a bridge can literally tell us it has a problem long before it's a catastrophe. Which really brings us to the final thought I want to leave you with. For all of human history, the materials we've used to build everything have been passive. They've been strong, sure, but they've been silent. We are now right at the beginning of an era where our materials can be designed with intelligence to actually be intelligent. So the real question is, what will we build next?